Okay, in this video, we have a voltage controlled amplifier. Okay, so pretty much if you build it, you can use all the parts that I've described here and test to see if it works. This is this resistor, the 85.9K resistor, is what sets the calibration. So how this amplifier works is that we put a voltage here, and I've got plus 10 sitting in here. So you can put anything from 0 to plus 10 here. And the way it works is if you have 10 volts in here, the amplifier gain up here, the overall gain of the entire amp is 10. So if you put one, the input is here, right on here. So we've got 1 volt coming into the amp, DC, and because we've set 10 here, we have an overall gain of 10. So we should get 10 volts out. We get very close to 10. So I'll show you that we can change the gain here, and I'm going to put it down to 5. So the output should drop to 5 volts, right? Let's go there. Okay, and it did. It went down to 5. Now let's also go down. Let's see how linear it is. So let's go down to 1 volt. And we get close to 1 volt out. So it's nice. It's pretty linear actually. And let's go down to 0.1 volt. So 0.1 is a gain of 1/10. So exactly, we got a gain of 1/10. 1 volt in divided by 10 is about 100 millivolts. So you can see it's quite nice and linear, and we can go really low in the gain. So I can go even 1 millivolt, let's say. So we should get 1 millivolt out. Yeah. So so now let's say let's put this back to gain of 10. Okay, 10. All right. So we get close to 10. Let's put this guy down really low. Let's put it down to 10 millivolt maybe. That's 10 millivolt. We should get 100 millivolt output. And we do, we get pretty close. So this also can work really nicely as a DC amplifier. And we can also set our gain of the DC amplifier just using a voltage here. So if I want the DC amplifier to have a gain of 10, I just put 10 volts here. If I want it to have a gain of 5, I'd put 5 here. If you need more gain, I believe you could calibrate it with just this resistor. Let's say, okay, so right now it's got a gain of 10. Let's see if we can go higher by changing this resistor. In other words, this is a scaling resistor. It's for calibrating. So what that means is the way I've got it set now, and the real value I've got here is actually 85.87K. So that calibrates it. So when I have 10 here, I get roughly 10 output here. Okay. And I adjusted that when I was pumping in 1 volt here. We had it set for 10 here, 10 here. So I had 5 volts out here, output, because 5 times 1 is 5 volts. But you can see it's not perfectly linear, okay, because this should really be 100 millivolts, but it's pretty good. That's only 4% out. And these are just garden variety transistors. These aren't really in the data here. I've got this set. The betas are all set to 100. But as you'll notice, if I like mess around with the beta in this, I'll take a look at the output left side. So if I imbalance the transistor, so this one's 50 and the one on the left is 100, it does change a bit. You see, it has changed it a bit. And let's go back up there, put that to 100. Okay. Okay, 100. Yeah, it changed it a lot there, but I think in the higher settings it doesn't change it as much. So these may have to be matched. This is like, I'm not sure how accurate. Let's say if we just went down to, let's change this to a beta of maybe 90. See what happens. So okay, it's still quite a bit off on the low value settings. And let's put it at 95. Okay. See how it gets a little closer, but it's still quite a bit out. It's supposed to be at 100 millivolts. 99. Let's see how that thing. That's getting pretty close, but still quite a bit out, eh? It's supposed to be 100. So let's put this back to 100. But I noticed something else before. So this is something new to me right now, but that's actually a good thing. Let's put this higher at a higher voltage. Let's go back to 100 or just 1 volt. Okay. So now let's put this around 5 again, sort of in the middle of the amplifier swing roughly. So we get a nice perfect 5. And this is perfectly calibrated for these type of inputs. But as you can see, it kind of slowly goes off a little bit from that. Now let's put this at 90 and see what happens to the 5 volts in the output there. See, it's not too bad when you run on a higher voltage level here. These transistors can be more imbalanced and they'll still give you pretty good results. So it really depends what you're doing with this. Now let's go down to 50 here. Okay, now that is out a bit, but not like, it's maybe out 20% or something like that, right? So, and these are really imbalanced quite a bit. So if you just take your transistors and put them on a beta tester and keep them pretty close, probably within 10%. So like I say, if I went, I'll go up now, I'll go 110, beta 110. So that's 10% higher than the other transistors. I'm still pretty close to 5, which isn't too bad, right? So it's more or less when this gets quite low that this number skews off quite a bit. So I guess that's why you'd want to try to get these betas as close as you can. So anyway, that's what I'm sort of seeing in the simulator, but definitely very usable as an amplifier. And let's say if you wanted to mess around with the gain, like for low level inputs, let's go here. Let's push this down to, let's go down to 100 millivolts. Okay. Okay, that's right. Gain of 5. Let's say we wanted a gain of 50. Well, then that we'd like to have that go to 5 volts, right? So let's just go down. Let's reduce this down till we get 5 here. Let's see if we can do that. I'm not sure if this will work. 8587. Okay, let's put this down to 30K. Well, maybe got to go lower. Down to 10, maybe. It's getting close now. Getting close. Let's go down to 7, maybe. Oh, it's a little too high at 7. See what happens at 8. Oh boy, almost right on. So now, instead of having a gain of 5, we actually have a gain of 50 just by setting this resistor. This resistor, what it does, it sets this whole bottom area is a voltage to current converter, and it's very linear. Some of them don't use the op-amp stages and they just have this and a resistor. They just have these bottom transistors and then plus a series resistor. This is much more linear. And so what happens as I change this resistor value, you can see it affects this current. If you're watching this current, see this one here, 606.7. And what was it, 84 before? Let's just go up to 84. I'll just put or 85 or something like that. I think it was. Let's watch that current. Okay, 606.7 microamps. It's dropped, eh? And when you have lower current here, the gain drops. Okay, because there's an equation for this, and you would take to calculate the gain, you look at the differential voltage. Well, this input voltage on the non-inverting side is 0, and in this one it's just 0.1 over here. Of course, it's the voltage that ends up at the base. So you'd have to kind of calculate what you got at the base. But how you calculate that, you look at the differential voltage between these two 1K resistors, and you multiply that by RC, which we really don't know. I had some resistors in here before. I think they were 200K. They kind of close approximation of what the transistors are doing. And so in a common emitter amplifier, it's just RC over RE plus little re. But in this case, you just have the little REs that you have to worry about. And what happens, this 57 microamps gets split in half each way. Okay. So you roughly get about 26 microamps in each direction. So to calculate the little RE, you go 26 milli over 26 micro, and that gives you little RE. But then you have to know this resistance here from this collector to the 12-volt source. And that's around, I believe it's around 200K. Let me zoom out. It's because I used some fixed resistor values before. Oh, there they are. They're hidden up there. Yeah, 220K I sort of approximated them to, but it's not going to be exact because these transistors going to react a little bit different, but they were kind of close in that range. So that's how you kind of calculate your gain. So it's the differential voltage between here and here. So there's two inputs at the base. Okay. Multiply. So you'd subtract these two voltages, and then you'd multiply that by that 220K divided by little re, or sorry, it's 26 milli divided by the current here, which is half of the branch. And so that's how you sort of get the gain. But I'll have to write the formulas out sometime for you, but that's not really that important for this explanation. I'm just trying to give you the idea that this resistance sets the current, and the higher currents give you more gain, okay? Because little re goes down, okay? And when it goes down, well, the gain goes up, okay? So that's the idea there. So let's put this back to 8, okay? And let's check its linearity. So I'm going to put 8K there again. Okay, now we should have a gain of, I've multiplied the gain. So I used to have 5 here, right? I used to have 5. So now it's 50. You can see that the output's gone. It's multiplied by 50, right? 0.1 times 50 is 5, right? Yeah, that's right. So now let's see how linear it is. So if I go edit this, and let's go to 200 milli, I should get close to 10 volts. Yeah, we're pretty close to 10. We could be getting close to sort of saturating the amplifier, but I'm not sure why it's a little, it's a little off. It's not too bad. Now let's go down the other way. Let's start going down the other way. Let's go to 50. So we had 5, so we should get about 2.5 volts, I think, at 50. Yeah, we should get around 2.5 on the output. Yeah, that's pretty close. Let's keep going down. Okay, let us go to 5 milli, and then that should be 0.25 volts. Let's just take that off. 0.25. So here it's out, right? 0.25 volts. We got almost 0.4 volts. So again, accuracy goes down at certain points, but for a lot of stuff, this will be great. So you can, because there can be a lot of I think at the lower current settings where that's lower gain, I think it's more linear. And that's something I've read about too. So if you run this at lower current, well, you got less gain, but you got more linearity. So keep that in mind, because you can always have multiple stages if you want better linearity. You could have another stage of this, or you could just have a constant gain stage, if you will. You could have another amp, or you could increase this amp stage, right? Like this. Well, this is actually kind of high already, but you could have another op amp with more gain if you need more gain, right? And that's easy to do. So I'm just showing you what's possible with this. Anyway, thank you very much for watching. I hope this has been informative. And one of the things I'll explain this before I go is this voltage to current generator. So this has a positive input here, and we're going into the inverting side. So we end up getting, if I put a positive 5 volts here, I'll actually get a negative 5 here. The negative 5 here will, because it's on the positive side of this amp, will give me a negative 5 here. This negative 5 will drop. This will be one diode drop above negative 5, so I guess it'd be negative 4.3 here, and that will be with respect to ground. So that sets the current through the 8K, which is the resistor that determines the constant current. And so whatever current is developed when you take negative 4.3 volts here, and divided by 8K. That's your current. That current flows. You can see it's going, the emitter current is the same as the collector current in here. It flows to this thing. And this is configured as a diode because of the way it's, this is shorted to the base here. So this just acts like a diode. And it allows that, it'll set the diode current to exactly the same current flowing through the 8K. And because this is kind of a mirror image of this transistor, whatever voltage drop from this base to this emitter is going to be exact same as this one here. It's going to set the same current, provided the transistors have equal beta. And then that current is going to be the one that feeds this line, right? And so that's how that works. So I hope that explains it. And these top two kind of work in a similar fashion on the top side of things. You know, this current here is going to be roughly the same as this. What I did find out by experiment, because normally they don't use the 2 megs. There might be some drawings that I've said that might use that, but a lot of times what they have instead of these 2 meg resistors, they don't use these at all. They just short this line here with the base, with one of the bases there, and that's it. So anyway, but I think this worked out better from my test in the simulator, so we'll leave it at that. So hopefully everything works when you build it, and let me know your results. Thank you very much.